All right, so first of all, nice to meet you, everybody. I'll introduce myself more formally in a second, but um, today we're going to be talking about data contracts and how you apply data contracts as a mechanism of data quality for artificial intelligence. So a bit about me to start. My name is Chad Sanderson. I spent the last 3 years leading the data platform team at a late stage growth startup in Seattle called Convoy, which was a freight technology company. It's a marketplace. And then on one side of the marketplace, we had shippers that were trying to move some freight from one facility to another. And then on the other side, we had carriers who were trucking businesses that were looking to take that freight. And our goal, like any marketplace, was to increase the supply and the demand so we get really good unit economics. And we used an enormous amount of artificial intelligence for that. We had many different algorithms that were running in production. We had a model that was predicting the ETA of any particular shipment. We had an offer relevance model. We had a pricing model and a bunch of other really interesting things. Prior to that, I was a tech lead on the artificial intelligence platform team over at Microsoft. I was the co-author of the Engineer's Guide to Data Contracts. I'm working on an O'Reilly book about data contracts coming out next year, so keep an eye out for that. And then I also run a community called Data Quality Camp. The link is at the bottom of the screen right there, dataquality.camp/Slack. Okay. So let's sort of talk about the world that the AI evangelists kind of imagine, right? Like we've got LLMs, generative AI, it's prevalent in every business now. What happens? Well, now you can ask ChatGPT or whatever your flavor of ChatGPT is in the next 6 months, maybe it's 6 or 7, any question you want about the business, and you get an immediate accurate answer. And that means you can say goodbye to analysts, right? Well, why do you need to hire analysts if we've got sort of this amazing, automated analyst that never sleeps? We could also theoretically ask the generative model to make a prediction, right? Hey, ChatGPT, I want you to tell me what is the likelihood of a customer churning from our website or not based on these 3 or 4 features. And ChatGPT could not only collect all that data, but then generate a predictive model that ML engineers could deploy. So do we really need data scientists anymore? And then sort of at the far end of this imaginary future, maybe you asked ChatGPT to look for bottlenecks in your product. Somehow by magic, it knows how your business works, it knows how all your services are connected, and you can discover business opportunities. And in that case, like, do we really need product managers? Do we even need product teams? Or can we have business users simply talking to ChatGPT and then generating all of the engineering that is required to support their ideas? Well, this is obviously a pipe dream, right? This is not the world that we live in today. And if you've ever worked with data for any substantial amount of time, then you know that good AI and BI, for that matter, fundamentally requires really good data. And the majority of data at companies who are looking to invest in AI is not so good. So I'm guessing that most of you in the chat have heard this term MLOps. And Andrew Ng, who was the creator of the term MLOps, he's also a co-founder of Coursera, and a really, really popular guy in the machine learning and data science space. And he had a quote, which is right here, which is that MLOps' most important task is to make high quality data available through all stages of the ML project lifecycle. So the important piece to capture here is MLOps' most important task. This is the primary responsibility of machine learning operations, is to make high quality data accessible to downstream consumers of that data. So that means that your AI system is not just code, it's not just the model and a bunch of training data that you pulled in from various sources like S3. It's actually very high quality data. It has to be refined, cleaned, validated, and semantically useful. So what happens to your models if your data quality is low? Well, number one, and I think this is the most obvious, you make wrong predictions, right? So a simple example of that is if you have a recommendation engine and you're collecting low quality data, then a customer who goes to a web page and you're showing them maybe what sort of products they may want to buy next, you could show them things that are completely irrelevant to them. So in that example, the worst case scenario is they don't want to shop with you anymore. But you can imagine that if you're a company that is, predicting someone's credit score and then using that predicted credit score to determine if they get a loan or not, having low quality data could have serious implications, not just on the business, you're introducing significant legal risk, but on your customer, right? Big implications for their life. So that's bad. The next thing is that your models stop working. We call these outages. And depending on the value of your model and how frequently that training data needs to be refreshed, this could be anywhere from a problem that costs, it's annoying and it costs a little bit of time and effort on the data team to fix, to a multi-million-dollar, 7 or even 8-figure problem, or potentially even more, depending, like I said, on the value of the AI. And then finally, in this new world of LLMs, we also have hallucinations. And a hallucination is essentially when a generative model gives you an answer very, very confidently that turns out to be incorrect. Now, the nature of LLMs is such that they are more likely to give you these type of hallucinations. However, if you have low quality data feeding into an LLM, then hallucination is almost guaranteed. And you can imagine how dangerous this would be if, say, your CEO was asking ChatGPT a question about, how many sales did we complete over the past 1 week? Or how many active customers do we have over the past 1 month? And the model confidently supplied completely incorrect data. It's very easy for a CEO to fly off the handle and make all sorts of irrational decisions. In fact, I've seen that happen many times prior to ChatGPT. So why is this common? Why is this problem so commonplace? Well, we need to talk about root causes a little bit. The first is that a lot of businesses have data pipelines that look like the image on the right. You have many different source systems that feed into dozens of downstream destinations, and all in between, you have intermediary tables that some people might understand, but a lot of people don't understand at all. So it's kind of like this big black box where data goes in and then data comes out the other side, but what happens in the middle is very, very unclear. And the longer your business is around, the more complex this web of data pipelines becomes. And you can imagine a single change to any one of these data sources or destinations can cause data quality issues to cascade throughout the whole system. Sometimes it's very noticeable, sometimes it's completely invisible. And now you imagine that these changes are happening constantly. We're going to get to that point in just a second. The second issue is that you have a lot of the same data replicated all over the place. And this is because in the modern software engineering environment, application developers are free to build whatever microservices that they want with whatever databases that they want. Their goal is to go as fast as possible, to experiment rapidly, and for that they need basically complete freedom. The problem is if people have complete freedom and there's really no sort of governance on which team is responsible for which set of data, you're going to see the same data used in multiple teams because a lot of that same data is useful for multiple teams. So a good example of this is this concept of a customer or an active customer. You might have 4 different databases that have some definition of customer. Like, oh, here's a list of all the free accounts of customers that have signed up and they haven't signed up for the paid version yet. But then you also have a database that includes active customers, which are people that are currently using the application right now. And there's probably some overlap between the free accounts and the active accounts, between the free accounts and the active customers. And then you have active accounts, and active accounts might be different from active customers. This might be at the organizational level, at the business level. If you're a B2B company, maybe you measure what active means a little bit differently. Maybe one team measures it as they've used the product within the last 6 months. Maybe another team defines it as they have actually, deployed some interesting feature, or they've done something interesting in the app like once a week or something like that. So you might have the same things with the same name, with very different business logic underneath. And then you may have something called churn customer, which is, well, these are people that maybe we want to target for remarketing campaigns, and we're collecting all of that data. And different tables are going to pull information. They're going to have to make some sort of semantic distinction on which database they want to pull from. And this leads to, like I said, a lot of duplication of the same concepts. Finally, the data is changing all the time. Software engineers, I call these people data producers, are consistently updating their databases. They're changing their applications. They're shipping new features. They're making adjustments to their back end. The rate of change is constant. And so you can imagine, if you've got a lot of duplicated data with a lot of business logic that hasn't really been semantically defined anywhere, and you've got these massive, very complex spider webbing data pipelines, if you introduce constant change into that system, you will be that will result in a violation of expectations basically every single day, and ultimately a violation of expectations is what causes data quality. So this is generally the reaction that different folks might have when they are told by their executive team that the roadmap is now shifting to generative AI. A lot of data scientists might be super excited that there's this new and interesting dynamic problem they get to work on, and the data engineers have a 1,000-yard stare because they're imagining the hellscape that will come along with their work. So if you feel these problems, then you're actually not alone, because I've spoken to not only just over 100 companies, it's actually over 1,000 companies at this point. And what I hear from every single data science team is that everybody cares about quality. Quality is one of the highest priorities. But if you then ask them, what percentage of those folks who care about quality think that their data is trustworthy, it is an unbelievably small number. And so this type of discrepancy means that there's likely something fundamentally wrong. There's a systemic problem here that we need to deal with if it's happening across the entire industry. So what are some of the high level causes of low data quality? So the first is if you don't have ownership, right? Most data starts off being used for an operational purpose, meaning a software engineer has an application, they're using some data in their application, in their service somewhere. It wasn't designed for ML or analytics for that matter. And the requirements for AI and the production system oftentimes diverge. And so if the software engineer is saying, look, I don't really care what you guys do with the data, I'm just going to make it accessible to you and you can figure out what to do with it, it means that they're not responsible for making changes that ultimately cause that pipeline to break. The second issue is that there's very limited awareness from top to bottom in how that data is being used. So again, if I'm a data producer, I don't know who's using my data. I don't know how important those use cases are. I don't know that when I change something, am I going to cause is it going to be backwards incompatible? And if there is a backwards incompatibility, how big of a deal is it for a company? Am I just causing a dashboard that nobody's looked at in the last 6 months to fail? Or am I causing a machine learning model that makes $100 million a year to blow up? Those are two very different outcomes, and they'll have a very different impact on my decision-making process. But most software engineers have no clue they don't have no idea how to answer any of those questions. The third is there's no change management. So the world is going to change. We can't stop the world from rotating. The question is, when things do have to change, how do you make sure that the people who should know about it actually know about it? And right now that doesn't exist today, right? If I'm a data producer, let's say I need to deprecate a field, I might go into a Slack channel and say, hey guys, I'm deprecating a field and I'm going to post this every single day for 30 days. And then when I deprecate the field, I have a lot of people come and yell at me because something of theirs blew up, because we're not connected to each other. I had no idea who was actually using that field, and the people who were using it probably weren't checking that Slack channel. Oh, whoops. And then finally, there's no form of semantic truth, meaning that I don't necessarily know what a single row in a table actually represents in the real world. And if you have things called OBTs, which stands for one big table, that means very, very wide tables with dozens or sometimes even hundreds of columns, it's extremely difficult to understand, like, what is a row? And in most data ecosystems, what I found, especially the complex ones, you have very limited documentation about what this data actually means in the real world. So the short sort of description of this problem is garbage in, garbage out, right? Once you have low quality data that flows into the system, it doesn't really matter what you do after that point. You're going to start to incur debt. And the question is, in the beginning, like, are you willing to, when are you willing to pay that debt down? When a company is relatively young, the debt is probably not unbelievably problematic, right? The data team can deal with it. They can write filters on top of their queries. But the longer and longer this goes on, in parallel, the length of the queries also starts to expand. So now you have SQL files that are 1,000 lines long and nobody knows what they mean anymore. And the data engineers and data scientists who worked on creating all that business logic left the company 3 or 4 years ago. So when that gets handed off to someone else, it's like, what the heck am I looking at here? I don't trust it. And that usually results in people going back up to the engineers, to the source systems and saying, what does this data mean? And then reconstructing the query. Now we have duplication, then the data changes, then the SQL file gets to be 1,000 lines long, and you're caught in a constant vicious cycle that spirals all the way down to the bottom. Pretty bleak picture I'm presenting here. But the reality is that there are solutions, but we need to think holistically about what those solutions are. And the conventional answers to these problems are not, don't work. And I know because I've tried every single one of these myself. The first thing that people, the first sort of things that people often think of to solve these problems are data catalogs and monitoring systems. So if you're not familiar with the data catalog, it's basically a big index of all of your data. So if you're using a cloud analytical database like Snowflake or Redshift or BigQuery, the data catalog would sit on top of that. It would scrape all the metadata and it would put it into an index and then give you a search box, kind of like Google, so you can find, type in the things that you need and it would just sort of pop up. This is useful for discovering what data exists, but it doesn't actually help any of the problems that I just mentioned, right? It doesn't help with the change management. It doesn't help with the fact that nobody knows, nobody has any sort of connection or relationship. So stuff is still going to break, but the catalog can effectively tell you when something has changed unexpectedly. And monitoring systems are very much the same thing. They're designed to sit on top of your analytical environment, potentially use a lot of fancy ML and statistics and look at drift and look at, unexpected distributions of data and things like this and say, hey, something's weird. I'm going to sound the alarm bell here. But again, they can't prevent the problem from happening. And that's what we care about. So this is, I would categorize this group of solutions as reactive, right? The thing has already happened. How do we figure out that it happened and then come up with some way to deal with it? There are things you can do to prevent data quality issues in the first place. One of which is having a governance committee, meaning you've got usually a multifunctional team of data scientists and software engineers and data platform engineers and data engineers, and everybody kind of sits down together and says, what are the rules and standards that we should be applying to our data? The problem is like most committees in the real world, this moves exceptionally slowly. And the rate of change in the business, as I just mentioned before, is exceptionally high, right? So it's very, very rare that a committee is going to be able to keep up with the rate of change in a modern software organization. The second sort of common solution to this is just having a data engineer or data scientist that sits into every meeting and every discussion of every single feature. The problem with that is it doesn't scale, right? I think this is actually the best solution of all four. It truly does solve the problem. I've spoken to maybe a couple dozen teams that were relatively small, where you had 20 or 30 software engineers and maybe 1 or 2 data engineers, 1 or 2 data scientists. And those companies generally had the fewest data quality issues because the data teams were able to sit in every meeting for every feature and they could represent their needs accurately and fairly. But if you're in a much bigger company with a few hundred software engineers or 500 or even 1,000, it's just not possible. You can't split yourself into that many directions simultaneously. Also, a real quick question to our moderators here. How should I deal with questions coming in? Should I stop and answer those now? Does it matter? Okay.
Yeah, you can go ahead and answer them.
Okay. All right. So I'm just looking at these now. So one from Josh, how do you approach who owns remediations of existing data quality issues? We are going to get to that. And then from Harvinus, Harvinivas, sorry about that. What are the KPIs that organizations should track to assess the effectiveness of their data quality efforts and adherence to data contracts? That's a great question. And I don't have that in the presentation, but I will get to it after I get through like the core of the technology piece. So I'll keep that in mind. So the high level solution here is that you need something that is preventative, something that's fast and keeps up with the rate of the change in the organization, and it's also scalable. This is where the data contract comes into play. This is the purpose of the data contract. So what I would want everyone to keep in mind as we go through a solution is that the purpose of the contract is not to be a wall, right? It's not to stop change from happening. It's to help data teams to differentiate between what is change that's totally okay for the data or perhaps even good, and what is change that is bad, that's negatively impacting you, and then connecting the data teams, the data consumers to the data producers at that point in time. So high level, what is a data contract? It's an API. It represents the state of the data, the expectations of the consumer at a particular point in time. And there's three core properties of the contract, but you can include many more than this. The first is the schema. The second is the semantics or the business logic within the data. So this might be, the value of a field. Maybe I have a primary key, that's a customer ID, and I always need that to be a 7-character string. And that's a rule that I want to put into the contract. And also SLA. So what is the freshness of the data that I expect? I need this data to refresh every single day because I have a machine learning model, and that machine learning model is trained every single day. So I need new data. Data contracts need to be enforced in CI/CD. So I'm going to get to this in another slide in just a second where I'll repeat the same thing, but a contract is not just documentation. It is documentation plus the enforcement mechanism together as a package. If you just have one, then you just have a catalog, right? And like I just said, catalogs are reactive. If you just have the enforcement mechanism, then you've got a test. And tests are cool, but they don't give you a lot of information. They don't give a feedback loop to the producer, and that's what we want. So the way that all of this works, at least at a high level, is that you create the contract. The contract has a corresponding check that is enforced in CI/CD. You observe the output of a data migration anytime that data is changed. You compare the new schema and the new business logic against the contract, and if it's backwards incompatible, then you can take some action. There's two types of actions that I think are pretty much universal. The first is blocking the change entirely. So if the downstream data product is way more important than whatever the upstream service is that's being changed, you can just say, hey, forget it. I'm going to block your build, right? You have no choice. I imagine that some super important AI systems at Amazon, for example, their recommendation system or their pricing model, like these types of things, there's probably nothing that you could change upstream without a lot of conversation if it's going to break those models, right? The second type of change is informational. And an informational change is when you actually, the primary goal is to build a relationship between the data producer and the data consumer. You want the producer to become aware of the new ways that their data is being leveraged. And if they're going to make a change that affects the downstream owners of that data, then they should have a conversation with you first. We'll talk about this a little bit more. So here's an example of a contract violation, right? There's me. Let's say that I am the owner of this sales order status contract, and I have an expectation that the categorical values that I receive from that from a field called order type are online and retail, but then I see a new field that I've never seen before that's called pop-up, and my model doesn't know what to do with pop-up. So there's three different stakeholders that we need to communicate three different sets of context to, right? When the data producer makes this change, I want to let them know that I have a dashboard that's used by the CFO that consumes the online and retail categorical fields, and that's going to break, right? The producer needs to know that. That's really important information. The data engineer needs to know that this is the person who maintains the pipeline, that someone is out there and they're proposing a pretty significant change to this order status table. And that potentially can impact a lot of people in the company. It can impact the business logic and many other expectations. So as a data engineer, I'm going to care about, at absolute minimum, getting in front of this change and being able to explain it to everybody that leverages this data. And then as a data consumer, I'm informed that like, hey, something is coming that's about to break me. That gives me a lot of agency in terms of what I do next. Either I can go back upstream into that PR and say, hey, don't do this. Let's have a conversation about it first. Or I can prepare my query to adjust for the incoming change. That way, whoever consumes my data, the CFO in this case, never actually sees the breaking issue to begin with. So high level here is that awareness is actually what leads to culture change. If everybody is aware of how data is changing and who it impacts all across the business, then you're going to start to make better decisions because you have more context and therefore more agency. Another really useful thing of data contracts is now you have a really clear understanding of which data is trustworthy, what data is not trustworthy, and what does it mean semantically. So if I have a contract on, let's say, my shipment database, then I know exactly, what is the domain to which this particular data applies. Does it have a contract? On which values is that contract enforced, and what do those properties within the contract actually mean? Like, and what are the constraints? This gives me a lot of confidence, so that, like, I don't have to go off and look at a 1,000-line SQL query and then go back and rebuild it myself. I can just say, oh, I know exactly what this data is. I know who the owner is, so I can reach out and talk to them directly if I want more context. But I feel comfortable taking a dependency on this information, and this can apply not only to databases like Postgres, but it can also apply to events like Amplitude or Google Analytics or Segment or any other upstream data source, Kafka topics as well. Third-party data is a bit of a conversation for another day. There are interesting things that you can do there if you're pulling something in from, let's say, Oracle or SAP or another API. But right now I'm focusing on first-party data just for the sake of simplicity. So high-level, overview of what you solve with the contract. So the first is you've got change management and change communication for 100% of all the assets that are under contract. So all of the upstream systems that you care about, if something changes, you will know, and you can insert yourself into that conversation. The second is that ownership is very clearly defined. The third is that you have the ability to prevent changes before they're actually deployed instead of dealing with the issues afterwards. You have a set of trustworthy data assets you can rely on instead of all of this like random nonsense in your analytical database. The producers have very clear awareness into how data is flowing throughout the organization and where that data is being used and how important it is. That means your machine learning models can make a lot more trustworthy predictions. All of the changes to the data are explainable. They're not just these random shifts. It's like trying to hold on to sand. And the data engineering team can scale quality by focusing on data quality where it matters and not trying to apply it to every single data asset in your data ecosystem. All right, so what is the contract and how do you implement one? The contract is composed of two parts, like I said. The first is the spec, and the second is the mechanism of enforcement. And I prefer CI/CD, but there's actually many places you can enforce a contract. So the contract spec has a few parts in it. I like to use YAML because YAML is very flexible. It makes it super easy to translate the config into CI/CD checks. So you always include the resource name. So there's a one-to-one mapping between your contract and whatever the data object is that you're trying to protect. You want to include the owner, the schema, like I mentioned, the data type, and also the tier. And I think tier is a really important concept. I usually have 3 tiers within my data contracts. 0 representing the most essential data. That's like, generating very clear value for the business, and 2, which is the highest. And that's like more experimental data. It's stuff that we would prefer not to break, but if there was a breaking change introduced, like we could probably deal with it. This is also very useful because it prevents just a lot of meaningless alerts from being generated all across a company and only focuses on the alerts for the data sets that actually really matter to the business. Here's an example of a contract, very, very simple contract. As you can see, it's all YAML. There's there's some documentation about what the contract actually applies to and what each field actually is. Something else that I like to do is that I don't allow people to publish contracts unless there is clearly defined documentation for every single field under contract. It's a really great way to sort of ensure that your the semantic truth of what the data actually is being defined. If a data consumer creates a contract and says, hey, here's what I think this particular field is, and then that data producer looks at that contract and says, oh, that's actually not how this field is being used, that's a really great conversation that can then happen about like data usage. The second thing that needs to be implemented here is the mechanism of enforcement. So I like taking all those YAML files, I put them into a single Git repository, and then I have a mechanism that's effectively like scanning that Git repository and uploading contracts into a service. You don't have to, that's a bit more complicated. You don't have to do it that complicated. You could do it totally manually if you want. But the enforcement mechanism is essentially you want to plug into the CI/CD mechanism if it exists within your company. There's always like some way of doing a data migration. You can either do it by hand or you can do it through some sort of automated system, but you can connect to whatever the output of that data migration actually is. And then you can compare that output with the CI/CD check against your contract definition. And you do that because you've already defined what the resource name is in your contract and in your CI/CD check. If that output, if the new version of the data is backwards incompatible, then you can take one of the actions in the tiers. So I have some GitHub actions that do all this. In fact, I've done it through GitHub Actions, through Circle CI orbs. And then I've also, when I was at Convoy, we just built a CLI that managed all this. So the tools are out there. All of this can be created on your own. And I wouldn't say it's the most difficult thing in the world. The challenge is more culturally, I would say. But like who implements this is a big question. Like who actually implements the CI/CD check on the upstream code repo? The best model I found is for it to be either data engineering or the data platform team. There's a current model in software right now. There's companies like Sneak. I don't know if you've ever heard of these guys, but these are companies like Sneak is a business where a security engineer can add a CI/CD check just like this into a code repo that they don't own, primarily for the purposes of observability, like checking Docker files and looking at the likelihood of vulnerabilities being introduced and stuff like that. And this is a pretty easy sell to any engineering organization. Like we're going to introduce a check. It's not going to be disruptive. We want to just understand if we're being broken. And if we are broken, then we want to have a conversation. I've never had a problem having this implemented. It's like pretty easy and straightforward. So here's sort of an outcome of one of these checks. And this is what actually appears in the when a change is made, when a change is deployed in GitHub, where that CI/CD check has failed. So a change in this PR has altered the schema of a data asset that's under contract. Review the changes and contact the contract owner to understand the impact. And then you can see here that there is a missing property and it's called invoice ID, and it has a certain type, and that property doesn't exist, and that's going to cause all sorts of issues. You can get as complex or as simple as you want with these types of messages. I actually lean more on the side of complexity. I like tagging the owners of the actual downstream data in the PR, and I also like allowing the data consumers to subscribe to contracts so they're automatically added as reviewers. But there's a lot of interesting things that you can do here. In terms of updates to the contract, because the contract does change over time, it's just a pull request, right? Everything's stored in Git. So if someone needs to go in and say, hey, I put 4 or 5 fields under contract to start off with, but I actually need 5 or 6, and maybe I need some additional constraints, that's a pull request. It gets reviewed by the owner. We have a discussion on if it's reasonable or not, and then we go from there. Let me just check QA real quick to make sure there's no questions that I should be answering. What are examples of some controls have been implemented? Data privacy, growing concern, data context. Yes, all great questions. You know what? I'm just going to deal with these at the end because I think they're all excellent questions. So in terms of the contract pipeline, the way that I think about enforcement here, because contracts are a form of governance, is that you want to focus on pipelines. You want to focus on pipelines. So you want to go vertical. You don't want to go horizontal. If you go in and say, you know what, I just want all of my data to be under contract, this isn't really a good thing for the software engineering team. They still need to be able to move quickly and make very iterative changes. And if all of a sudden you tell them, hey, you're going to need to slow down and start caring about every single consumer of your data, even if the consumers of that data are not doing anything important, you're probably going to have a bad time. Where it's really easy to sell this is if you can say, hey, this specific pipeline is supporting a data asset that's really, really valuable. Here is all of the sources to that asset. And this has a real financial implication if we introduce data quality issues. Like, that's a very easy thing to get approval of. And to just quantify, generally speaking, to the business and like, why is data quality valuable in the first place? I mentioned before that catalogs and monitoring solutions were not the end all be all. That doesn't mean I think there's anything wrong with them. In fact, I love catalogs. I've implemented many catalogs, and I also really like monitoring solutions. And data contracts, you can essentially scan. The reason I like putting all of my contracts in one repo is so that you can easily scan that repo and you can upload it to a data cataloging solution. It just makes it really simple to do that. And then in your catalog, you can differentiate between what is all the data that we have that's under contract and what is not. And that lets people do, very easy filters and only focus on the trustworthy data, see how any particular contract has changed over time and things like that. And then for your monitoring solution, it's basically impossible to come up with a contract that is 100% effective from day one, because you don't know what you don't know, right? Like, you're going to learn more things about the data. You're going to learn more things about the business. There'll be more features introduced. So what you need is a solid baseline for the contract, and you need a way of iterating over it across time. And the monitoring solution, like DBT tests or something more holistic like Monte Carlo, is really good for that, right? Once you can detect, oh, this particular asset is now being impacted by some really weird set of null distributions, and I actually want to keep the null distribution really low, like below 2%, you can now go back to the producer, the owner of that contract, and say, hey, I have a new constraint that I'd like to add, and here's all my evidence, and here's how it's impacting me. And that makes it a really fruitful conversation. So last big question, don't you need to change culture before implementing data contracts? This is probably what I get asked most frequently. And I get it, right? Like, this seems like, wow, we got to get the producers to care. We got to get the consumers to do work. We got to get data engineers to do work. How do we actually get people to do this? Well, here's the question that I always like asking everyone, which is, imagine that you just started work at a new company and you were tasked with implementing agile software development, right? Like highly iterative, rapid deployment. And you have two options on how you do that. Option number one is you go to every single product team and you have them read the Agile Manifesto, which I think there's a couple books on it, and there's a bunch of articles, and there's like a 14-point document. So we could either go through those 14 points point by point, and we could read it and we could talk about it, and then we could try to push it up to the CEO and get them to enforce it and top down. That's one mechanism. Or you can start by introducing version control or CI/CD or GitHub or Jira. Which one of these do you think would be a better starting point? Well, in my opinion, it's the latter. And the reason it's the latter is because the former creates a whole bunch of process and the latter actually creates value, right? There are good things that engineers get by using version control and CI/CD and GitHub and Jira. It makes their lives better. And if I have a product engineering team that is using version control and they're using CI/CD and everything goes out with a pull request, and we have all of our projects tracked in Jira, we're 80% of the way to Agile, and the engineer doesn't even need to know what it is, right? So my belief system here is that once it is very simple and easy for everybody to do the right thing, then you can start to layer culture on top. But if you try to go the inverse direction, it doesn't really work. If it's really, really challenging and painful for everybody to do the right thing, then it's extremely difficult to change culture. So the high level of data contracts is that they make the transition to producer-owned data quality much, much easier. And that's because there's a built-in incentive for everybody in the value chain. So data engineers, they usually feel a lot of this pain because they're being sandwiched on both sides. And so the data engineer can go take the incentive to implement. The data consumer obviously cares about this a lot because they don't want to be broken. And the data producer, you give them visibility, right? You help them understand, where is your data actually being used? Where is it broken? What outages are you potentially going to be causing, right? Everybody actually has an incentive to use that system, and that makes the transition easy. So that's the end of my presentation. thank you. And I guess now we can start to do some Q&A. All right. Let's see. All right. So question number 1 from Josh. How do you approach who owns the remediation of existing data quality issues? Yeah, that's a really good question. So basically the idea is really the system that I've been talking about is one where you're kind of living in an okay world, and then a data quality issue is introduced, right? And you're helping someone understand that they're causing a problem. But what happens when you're already facing a problem? Unfortunately, I don't think there's a great solution to this. I think that you do have to work with the data engineer to come up with like a bit of a tech debt oriented issue where you layer on a filter, or you do a backfilling job upstream, and you prepare for the next time. And I think the faster that you can build that bridge between the data producer and the data consumer, the easier it is to eventually get to the point where the producer says, hey, what are all the things that I can help you with from a perspective of data quality? And that's going to be unwinding a lot of the mess that was originally created. I can tell you at Convoy, when we rolled this system out, it was literally an overnight switch with our software engineers. They went from saying, I don't care about data, it's not important to me, to seeing how the data was used. Like, whoa, wait a second. We have a pricing model at Convoy that makes us $500 million a year, and that depends on 3 columns that I use, and no one ever told me this. What the heck is going on? So they immediately started caring about unit testing and integration testing and quality and things like that. And after that, it was very easy to bubble this up at the organizational level and get real resourcing behind it. So yeah, that's sort of my answer to that. What are the KPIs that organizations should track to assess the effectiveness of their data quality and adherence to data contracts? Good question. I actually think there's some really awesome metrics for this. So when I was at Convoy, we used a metric called contract coverage. That's pretty similar to code coverage for services. So we would map out what our tier 1 data assets or data services was, like, oh, here's all the training sets for our models. Here's all the data that we're vending out to a customer. And then we would say, what percentage of the sources for these downstream systems have contracts on them? And then we can express that as a ratio, and that gets across the level of risk that any particular data consumer has, right? If only 10% of the upstream sources have contracts, that means that you have a 90% risk exposure rate. And that's scary. And it's something that you can go and talk to a product manager about or a business user about, and they generally understand risk pretty well. Okay, next. What are examples of some controls that businesses and organizations should implement? Data contracts? I'm just kidding. So I think there's a lot of sort of other governance work that you can do to layer around the contract. But the reason I love starting with contracts is because it's actually not even attempting to solve a technical problem. It's attempting to solve this big people problem, which is that we've just got this gap in communication between the data producers and the data consumers. Once you solve that communication gap, then there's a lot of interesting avenues that open up in terms of business controls that you can begin to layer on top of that system. But it's like I said before, it's really, really hard to have that conversation if the two sides are not even talking to each other. Data privacy is a growing concern. How can data contracts incorporate privacy considerations, especially when handling personally identifiable information? Excellent question. Well, because the contract really deals with metadata, and PII is something that can absolutely be enforced programmatically, there's really nothing stopping you from having PII constraints in your contract. And those constraints can apply to the way that software engineers treat that data, but you can also go bidirectionally. So this is a bit of advanced data contracts, but if you implement a data lineage solution, so you're able to map your data source to, your analytical database and then see how the data actually flows at the column level, throughout your entire business, then you can track, hey, where is all of our PII going? And in order to use that PII, we're going to add a rule which says you actually have to get approval from the contract owner first. So this is actually how companies like Google do it, but it's way less automated than this. And also it's a literal contract with like a piece of paper and a pen. So, but ultimately, like, I think that you can incorporate PII into a contract mechanism in really interesting ways. From Josh, can data contracts handle changing semantics for the same value? Like when one meant Bob, but changes to mean Sally? assuming there's not a lookup table, which there should be. So so there's sort of two ways that I'm interpreting this. I think one is the very I think one is the very easy answer, which is that if you have an unexpected value, then the contract could certainly catch that. I think the other is a little bit different, which is let's say that, like, I'll give you an example of this from Convoy. We had a column called shipment distance, and shipment distance was expressed in miles. And there was one day that a software engineer decided to express shipment distance in kilometers. This doesn't change the data type. The data itself just changes. Now, I think that there are some interesting things that you can do I think there are some interesting things that you can do. So for example, if you can detect that the data is somehow being changed in a preventative fashion, you can pop an alert to the software engineer and say, here are the semantics that we expect from this data that's under contract. Are these still true, right? I don't know exactly which column that you're changing, but I do know that you're going to be making a change to this database. And I know in that database, there's something under contract that's called the shipment distance column. And I always expect miles from that. Is it still miles? And if the answer is no, that's the time when the data producer can basically provide that information. And you can actually require them to fill this out, or at least just check a box before they actually go through a deployment. If they haven't broken anything, then it's like a 10 or 20-second process. If they have, then that's a place that you can catch it. Outside of that, there are checks that you have to do. There are some things that you can't check in CI/CD. You have to do the check after the data has, either you need to have a testing process where you run maybe a couple thousand rows of data through like whatever the new version of the database is in a test environment, and then do a diff, compare the two data sets against each other, and probably let a consumer take a look at it and see if anything weird is happening. That's very advanced. I also have opinions on how to do that, but I don't suggest starting there because it is extremely hard to do and expensive to build. But you can also do checks after the data is in flight, right? Or right before it's in flight. So you can do checks at runtime against the contract. You can do checks if you're using a streaming system, when the data is actually, moving between systems. Like you can run Flink SQL and have a constraint check there, or you can do checks after the data has already landed. It may not ever be 100% comprehensive, but there is a lot of guardrails that you can put into place between when the data is deployed and when it finally reaches the consumer. Okay, is it cool if we access these slides? Absolutely. I mean, I think so. I think it's cool. I'll defer to the moderators, but I would be more than happy to send these out to everybody if you would like them. From Sammy, I am also interested in data contracts with third-party data. Would you be giving a talk in this area? I would love to. As you might be able to tell, this is a very deep space. And so I could probably do another hour-long presentation just on contracts for third-party data. I might start putting something like that together. But if you want to know more, just reach out to me directly. You can look me up on LinkedIn or email or something, and we can have a one-on-one conversation about that. Next, from Dong Yang. I love the idea of implementing data contracts, but my team, which is quite small, prefers maintaining our data purely in the databases. How do we implement data contracts if our data only exists in databases and not available in Git? Yeah, that's kind of a tough one, unfortunately. And this is what I mentioned before, which was what I have found is that in teams that are pretty small, pretty small software engineering teams, it's relatively challenging to get folks to see the impact of data quality issues because there's not enough production implication if the data fails, right? That's a pretty strong requirement. However, I think that you can, at the very least, start getting folks to think about contracts, even if you're just using a Word document, right? Going to software engineers and saying, hey guys, we need to have an equivalent of integration testing for our data because I use it and it's actually really important to me. And I would really like to make sure that when you're making changes, it's backwards compatible. So here's a document that just describes what is the data that I expect? What are the data types? What do I expect the data to mean? And let's just get into the habit of reviewing that document anytime you make a change. Since you're still so early, I think that's something that's pretty reasonable, right? No engineer should be like, no, like I refuse to do that. Once you get to be a 1,000-person company, that's where that conversation becomes hard to enforce across the entire organization. But when you're small, just doing pure documentation, I think, is actually quite effective. Another question about third parties. I will sort of answer that hopefully at some point in the future. One question about getting access to the recording. I don't know what the policy is of Data Science Dojo, but hopefully that's a thumbs up. From Harinivas again, in regulated industries, how much time do I have? I have 5 minutes. Okay. In regulated industries like healthcare or finance, data compliance is critical. How can data contracts align with regulatory requirements? And what strategies should organizations adopt to ensure compliance? Yeah, I think that's a great question. And it kind of maps onto the PII question I was answering earlier. Really, think about the best way to think about the data contract is it's sort of your compliance and governance playground. As long as you have, I call it data governance as code. As long as you have a mechanism of enforcement somewhere, then you should be able to add the constraint to the contract. So I've never worked in healthcare, although I understand, you've got HIPAA, you've got all these other rules that are pretty explicit in how data needs to be treated and moved within the organization. And if you can codify those as some type of check, ideally that exists in a preventative environment, then the sky's kind of the limit. In fact, there are some healthcare and lots of finance organizations as well that I might add that are beginning to leverage contracts exactly for that purpose. In fact, a lot of the big banks already have data contracts. They just don't have them in the exact sort of iterative, scalable technology type of way that I just described to you. Okay, Sammy again. So you recommend that any new data analytics / data science projects start off with implementing data contracts? Actually, no. So what I would suggest is that the world of data science it's not like software engineering. In software engineering, you have very explicit functional requirements, right? I have to build A, B, C, and D. If I build A, B, C, and D, then the user will use it in this way. And then we just deploy it and try to see if we're correct. But in data and data science, it's not really that straightforward, right? Someone may come up with a question that could be purely hypothetical. Like, oh, I wonder if we could see how many users, I'd really like to see how many users are dropping off after their very first page view, right? Like that might be an interesting thing to solve, or it might be completely useless. So whenever you're starting a new project, I think that it's important to still have the flexibility to iterate and go as fast as you can. But once you get to a point where you've done your iteration, maybe you've even deployed into production, and now you know for sure that the answer to that question is very, very useful, and you need to ensure that nothing breaks. Now is the time to create that data contract on the upstream data source and provide the information to the producer that they have a new critical dependency. And that's what starts creating the connection. So there's, again, very, very high ceiling here for these, lots of things we could talk about, but I have a whole other presentation that I do on how I think environments for data are completely busted. I think that data teams have basically copied software engineering teams in terms of they're like, oh, we have tests, we have QA, we have production. That's not what data needs. What data needs is a prototyping environment, and they need a production environment. And I think the contract is the mechanism that differentiates between the two. Okay. 2 minutes left. Do we have any other questions? Let's see. There's one from Jordy. Data contracts transformed how my former company related to data. Trust in data skyrocketed. Rollout of AI products accelerated from months to weeks. Resolution of DQ issues went down from months to days, and the CEO would go on stage to congratulate the departments with the biggest data quality improvement. Wow. Okay. Well, you can't really get much more of a glowing recommendation of data contracts than that. That's awesome. And I would love to talk to you, Jordy, because I would love to, well, maybe, I guess it's a former company, so maybe it doesn't matter so much anymore, but I love putting really great implementations of data contracts and data quality solutions in general on display. So I would be happy to give you a shout out there. I have reached the end of my time, everyone. It's 9:59 a.m. here in Seattle. So thank you for being an attentive audience. Please, like I said, if you're interested in this topic more, look me up on LinkedIn, just Chad Sanderson, I'll pop up. And you can send me an email as well. My email is csanderson.data@gmail.com. Happy to talk about this issue at any time. So
thank you so much, Chad, for such a great session. I think this was a very engaging audience. Thank you, everybody. Two questions that I would like to address because you were talking about them and we didn't have much clarity earlier. But the recording is available both on our YouTube channel, for which the links we have shared, and also on our webpage. And any resources that have been shared during the presentation will be linked alongside the recording of your live event. Other than that, because we have so many people who are wanting to connect with you, Chad, we have a Discord server where we encourage the speakers to interact with the audience members so that any questions that were not answered in much detail can be answered there, and then you can keep the discussion going. And then if we have any more webinars with you, because I see that already there are so many people from the audience who are wanting for you to present on a couple more things in much more detail, we can just announce it to the people over there.